Every single second of the day, dozens of Amazon boxes are shipped out and moving across America. But, have you ever stopped to wonder just where those millions of boxes actually come from? How exactly does a single factory pump out enough perfectly constructed boxes to wrap entire cities, day in and day out? Well, today, we're taking a fascinating tour inside one of America's most advanced manufacturing processes. We're going to see where raw speed, pinpoint precision, and some seriously heavy automation come together to engineer something we all just kind of take for granted.
Just think about the absolute scale required here. I mean, you order a new smartphone, right? Then maybe a bulky laptop, a new pair of shoes, or even your weekly groceries. Each of those totally unique products needs a perfectly sized box to keep it safe during transit. And because millions of packages are shipped daily across the country, millions of cardboard boxes have to be manufactured continuously just to keep up with that demand. It's literally a logistical puzzle of epic proportions.
Okay, let's dive into this. Imagine if production at these massive facilities stopped for just one day, just 24 hours. Amazon's entire delivery network would slow down dramatically. The ripple effect would be absolutely massive. And that is exactly why these factories literally never sleep. Many of them operate 24 hours a day, 7 days a week. It's this non-stop, high-stakes operation that demands flawless engineering, all to prevent the entire supply chain from just coming to a grinding halt.
Section 1. Engineering corrugated cardboard strength.
So, the journey starts with something absolutely huge. Instead of starting with small, pre-cut sheets, these factories receive giant rolls of corrugated paper. And when I say giant, I mean each roll weighs several tons. That's about the weight of an adult hippopotamus, and many are actually taller than a person. Obviously, you can't just move these by hand. Special automated cranes carefully lift these massive rolls right onto the factory machines. And the stakes are high here. One single mistake could damage thousands of dollars worth of material in an instant. Because of this, the whole shebang is controlled by computers with advanced sensors constantly measuring alignment with just incredible precision.
Now here is where the real manufacturing magic happens. Flat paper on its own, well, it's just not nearly strong enough to protect your deliveries. So the factory has to engineer corrugated cardboard through a really brilliant step-by-step process. First, a giant machine takes one paper layer and forms it into these tiny structural waves, a process known as fluting. Next up, glue is applied completely automatically. And finally, two flat sheets are pressed tightly onto both sides of that wavy middle layer.
It's a completely fascinating contrast. You go from flat, fragile paper to a highly engineered, lightweight, but incredibly strong corrugated board. That fluted layer we just talked about, that's the secret sauce behind the cardboard strength. It is the structural difference between a weak piece of paper and a sturdy box that can safely protect heavy laptops, large flat-screen TVs, fragile glass products, and countless other everyday items bouncing around in the back of a delivery van.
Section 2. High-speed shaping and printing.
All right, things get incredibly exciting right about here. The freshly pressed cardboard enters these machines that are moving literally faster than most people can run. Gigantic rollers violently but smoothly pull the material through the assembly line, and as it rushes by, computer-controlled blades cut the cardboard instantly. We're not talking rough cuts either. Every single cut is measured within tiny fractions of a millimeter. Laser sensors are constantly firing, inspecting each sheet so that even the smallest defect is detected immediately, ensuring the factory wastes almost nothing.
To put this into perspective, the sheer, unbelievable scale of this equipment is just mind-blowing. Some of these box-making machines stretch over 300 feet long. That is an entire football field of high-speed manufacturing. Depending on the box size and the design being run, certain production lines can manufacture tens of thousands of boxes an hour. It is quite literally a torrent of cardboard flying through these massive metal structures.
Right after getting cut to length, we hit the branding phase. Large flexographic printers apply high-quality ink directly onto the cardboard, and they're capable of printing several colors in a single pass. It perfectly aligns that famous Amazon smile in seconds. Honestly, one small printing error and the box is automatically rejected. From there, the sheets move to die-cutting machines. Powerful steel dies press violently against the cardboard in one impossibly fast motion, instantly creating every fold, flap, and locking tab. Thousands of boxes are shaped per hour in a blur of motion that almost feels impossible to even watch.
Section 3. Robotic stacking and quality.
Once those boxes are finished, they rush onto conveyors where robotic arms take over. These robots grab entire stacks of finished boxes all at once. They never get tired, and they never ever lose focus. Guided by highly advanced vision systems that detect exact positions, these robotic arms move with untiring precision. They ensure that each stack is perfectly aligned and prepped, totally ready for the next stage of shipping.
But hey, before anything actually leaves the factory floor, every batch undergoes rigorous testing. Engineers rely on automated systems and physical checks to verify strength, fold quality, printing accuracy, and exact dimensions. And they don't just look at them either. Actually, some boxes are intentionally crushed to test their failure points, which honestly sounds like a highly satisfying job, while others are purposefully exposed to moisture to test their durability against the elements. Only the boxes that pass these incredibly strict standards ever make it out to Amazon warehouses.
Section 4, Recycling and Final Delivery.
And this part brilliantly illustrates the closed-loop engineering of the modern factory. Nothing goes to waste here. Every time those steel dies punch out a box, the cardboard scraps are collected automatically. Huge vacuum systems run throughout the factory, instantly transporting waste paper away from the line. Those scraps are then recycled directly back into brand new cardboard rolls. By recycling thousands of tons of paper every single year, these factories drastically reduce waste while simultaneously lowering their production costs. It's a total win-win. Finally, those perfectly stacked flat-packed boxes are automatically wrapped into massive bundles. Forklifts scoop up these huge pallets and transport them directly to waiting trucks. Each truck is loaded with thousands of boxes, which are then driven straight to Amazon fulfillment centers. It's amazing to think that within just a matter of hours, those very same boxes might be filled with products and headed directly to your doorstep. So, I want to leave you with this question to think about. Are you going to look at your next Amazon package a little differently? The next time a package arrives at your home, remember the engineering marvel it took to get it there. That simple cardboard box began as a multi-ton paper roll, passed through a 300-foot gauntlet of high-speed machines, was analyzed by laser sensors, punched by steel dies, and stacked by tireless robots. It really is a masterpiece of modern, highly efficient manufacturing. Thanks for joining me on this explainer, and I hope this sparked your curiosity about the incredible engineering